All right. Hello, everyone. We're live. This is Tom Clark from ITV, who is the head of
Common Platform.
And he's going to give us a talk about roughly how they do what we do in the cloud that they operate in, which might even be AWS. I don't.
It is, yeah.
Okay, cool.
Yeah, I can reveal that. No big secrets.
Lots of commonality, I hope.
Yeah, good.
So
cool.
Over to you.
Thanks, Pete. Okay, so hello everyone. Thank you for coming along this afternoon. I'm Tom Clark, head of Common Platform ITV. Common Platform is our next generation hosting platform, and this is its story. But first, a little bit of kind of context about how ITV is structured. So there's 5 main divisions of ITV. So this is going to be interesting. Okay. Okay, so there's 5 main divisions of ITV. So there's studios. See what the lag is like on this. This is quite interesting if there's a 5-second lag between the. So. Okay. Okay, we'll have to see. Okay, so there's studios who make stuff. So we make stuff for ITV, like you'd recognise, like Jeremy Kyle. But we also make stuff for other broadcasters as well. So we actually make kind of a university challenge for the BBC. Okay, so there's commercial who sell stuff. So that's selling stuff like adverts you see in Emmerdale and Coronation Street. But it's also actually licenses and rights to formats that we own. So you may kind of watch Come Dine With Me. You think it's a Channel 4 show. We actually own the format to that, and we sell it to people around the world. So in Germany, if you're watching it, you're watching Das Perfect Dinner, and we make some money from that. Broadcast. I think I found the trick now. Okay. Broadcast. They distribute stuff over the air. It's where all of our kind of antenna and broadcast technology live. There's online as well. And they distribute stuff online, surprisingly. It's actually where the ITV hub, or the player as it was, lives. And then finally, there's shared services, which is where everything else lives. It's where HR, legal, finance, all those kind of systems like that, they all live in shared services. So some useful context for the rest of the presentation. So I'm going to talk a little bit about the journey of the Common Platform, where we came from, where we're going to, and how we got there. So first, we need to wind back to 2010. So 2010, ITV's share price had plummeted to 18 pence a share, and we were about to go bust. Adam Crozier kind of came in to save the day, and one of the things he did as part of his massive kind of cost-saving exercise was to outsource all of our technology infrastructure to a managed service provider. But it kind of made sense at the time. It actually saved us loads of money. And, you know, VMs took weeks to be delivered. That didn't really matter, you know, because actually we were a waterfall shop, and you could put on your Gantt chart, and actually it wasn't the end of the world. And admittedly, the installs, they were scripted, as in a paper script that someone followed in Bangalore, kind of hopefully to the letter. We had the dev and ops divide, but you know, it wasn't so bad. They threw it over the fence, and we cried, but it was okay. We introduced Puppet as configuration management, initially to clean up the VMs that we got from the managed service provider. You know, it did things like uninstall X Windows from our server and disable the R-star services from our servers in the 21st century. We then started using Puppet to configure the applications that we ran on our servers as well. Eventually added CI systems like Jenkins. And we stopped crowdsourcing our monitoring from Twitter. It's really cheap and effective, but actually we find actual monitoring tools work a lot better. So let's fast forward to 2014. The ITV player, as it was then, we wanted to put it on the Samsung connected TVs. We called it our 10-foot system because you sit 10 foot away from the UI. We wanted to do this, and we wanted to do it a bit differently. So there's a guy called Rob Taylor at ITV, and he's a pioneer in the Wardley sense. So Simon Wardley talks about pioneers, settlers, and town planners. Rob is a pioneer. He has a great idea. He convinces people that we should give it a shot, and he assembles kind of like an MVP thin slice team to deliver it. Great. So he got his team together, and he said, you know, product team, dev, ops, put them together. Maybe we can try this. He got the approval. He put dev and ops together, rubbed them together, put the application for the VMs, and he waited. They waited, and they waited a little bit more. And eventually they got tired of waiting. They got their credit card out, they went rogue, and they went to AWS. And they put the entire thing up and running in about 6 weeks. So I get told off by my bosses when he would say it was quite as gung-ho as that, but it actually wasn't too far from the truth. So what did that show us? It showed ITV that DevOps or product teams could work as a way of delivering software to ITV. And it also showed that the cloud worked, and actually it wasn't as scary as we thought it was. So let's fast forward. Let's try and fast forward. So let's fast forward to March last year. So we were, as part of the cost-saving exercise, we'd basically put all of our program development on hold for about 5 years, on ice. And we kind of realized actually we were slipping behind our competitors. And we thought, okay, we need to do something about this. We need to modernize all these applications. Some of them were still written in COBOL. We need to modernize these systems. We need a modernization program. And we looked at the existing platform we had, a waterfall kind of based platform. We thought, nah. And we looked at the common platform. We thought, well, maybe we could do something with that. So I was asked to make it a thing. And I did. So if Rob's a pioneer in a Wardley sense, then I'm a settler. I come in after the pioneer, I take what they've done, the great work, and I make it industrialize it, I commercialize it, I make it production ready. So that's what I did. So let's fast forward to today. It's a thing, you know. We now have 12 instances of the common platform, and I'll explain what I mean by instance later on. And about 13 engineers, up from about 3 when I started. And so this is essentially the story of how we did that. So ITV is a FTSE 100 company. So there we go. ITV is a FTSE 100 company. You know, we're always being asked to do more with less. That's the problem we're trying to solve. You know, and you know, we answer to Adam Crozier, we answer to the shareholders. We're always trying to be as efficient as possible. The term we use at ITV is lean. Every decision we make should either be making money or saving money. And it sounds quite harsh, but and it is like pure capitalism. But it really kind of focuses your mind. Like, is this going to make money or save money? So it's kind of an interesting way to work. So how do we do that with a common platform? So there we go. So key one, really, really obvious. You automate the boring, mundane, repetitive stuff. You've got smart people on your team. They get really, really bored really, really quickly. And if you ask them to do boring stuff, they're going to leave. And also, actually, if you do repetitive, boring stuff regularly, you start making mistakes and it ruins your standard deviations. So automate the boring, repetitive stuff. It means you can concentrate on the interesting, fun stuff like drinking coffee or beer or watching the football. The cool thing about automation as well is the more you automate, the more time you have. And the more time you have, the more automation you can do. And that gives you more time, you can do more automation, and you get this into this cool infinite loop. It's really cool. The next key one is standardization. So essentially with standardization, it means you can make assumptions. Assumptions mean you can move quickly. Rather than having to double check and second guess everything you do, if you know it's standardized and you know you've all agreed to use round pegs across the board, I know I can use this here and it's standard there and it's standard there. I can actually just like use the same tools across the board and steal from people. I can take that project's work and I know it's going to slot into there as well. The other advantage as well is that because you're totally standardized, it means a little kind of incremental benefit here. Everyone else across here will also benefit from the same kind of benefit as well. So you can all kind of upgrade and actually everyone benefits from your work. Next key one, loosely coupled but highly aligned. So I mentioned standardization before as well, and I mentioned these incremental improvements. They're all great, but if you make an improvement here and everyone has to down tools across the entire board to actually kind of accept your improvement, you're highly coupled. It's going to slow you down rather than speed you up. So we're always asking ourselves, how can we actually be loosely coupled but heading in the same direction? So loosely coupled but highly aligned. So these are kind of the main tenets we look for when we're trying to build this stuff on the common platform. Blast radius reduction, a kind of a personal favorite of mine. So blast radius reduction is the term we have for the area of effect of something going catastrophically wrong. You're making a change and it goes wrong. How many things can you kill if that change goes wrong? So there must be a time at ITV when there's lots of shared infrastructure, storage, virtualization, networking, whichever bit you want to talk about. It was very, very shared. And you imagine there was a failure. You know, there's a change that was made and it took the whole thing down. And you know, someone thought, I know, what process, that's going to fix that. So they would have added a cab, you know, a change approval board. And you go into the cab and you say, please, sir, may I do my release? And they say, yes, yes, you may do your release, you may. And you kind of back out, very, very grateful that you've been blessed to do your particular release. So that kind of makes sense in some systems. But if you can limit the blast radius, if you can draw a very, very safe protective fence around your application, and you can say, even if it goes horribly catastrophically wrong, you can't possibly affect anyone else, that means you probably don't need to go upstairs to go and get permission. You can actually devolve that responsibility for change down to the product owner. And if you say to that product owner, it's your responsibility for your product to be available, you empower them to make that decision themselves. If they want to make a release on a Friday and they can't possibly hurt anyone else, and they're bonused on the availability of the application, who better to make that call? You build it, you run it. So this is actually kind of a really, really kind of key tenet, actually. We don't have operations teams at ITV anymore. These product teams run it end to end. So dev, stage, production, QA, the same team that builds it is the same team that runs it. So they all suffer the pain. We have found that you give people responsibility and they'll want to make it work. Call it pride, call it hubris, call it what you will, but you get quality through psychology rather than process. Good people want to do good stuff. And if they don't, they're not good and you shouldn't have them working on your team. So those are some of the kind of the key kind of tenets we talk about with the common platform. But now we're going to see how we apply them to the classic three, the trifecta of people, process, and technology. So we're going to touch on a few different areas now. So technology. So Puppet. Puppet, for example, do you use Puppet here as your configuration management tool, or what configuration management tool do you use?
We just use Amazon CloudFormation and Amazon Code Deploy to do most config management. We use Packer to build our machine images, but that's it.
Okay, cool. Okay, so we'll use Puppet for kind of config management on the actual kind of the machines themselves. So going back to this kind of this time with the very large blast radius, going back to the kind of the 2010 days, we had one repo for Puppet. It's called Linux Puppet, and every team was using Puppet. It was all in the same repo, so it was incredibly brittle. A team over here made a change, and suddenly they'd wiped out productivity potentially for days for all the other teams. You know, kind of massive blast radius, really, really dangerous. So how do we fix that?
We have the same sort of thing when somebody changes firewall rules because they're managed centrally.
So how do we fix that? You know, we've actually now got one infra repo per product. So each product team has their own infra repo in GitHub. And that's got their Puppet code, their Terraform code, all their kind of different modules. They're all kind of restricted into that particular repo. Now, the cool thing about that, you get limited blast radius. You know, the blast radius is limited to your particular product. You make a horrible config change in your config management, you can only affect your product. The other important thing as well, it really increases your signal-to-noise ratio. The only changes going into that particular repo, by definition, can only affect that particular product. So you know the signal-to-noise ratio is really, really high. So if you have an integration with Slack or something that alerts on every single commit, you know that actually the quality of that message is going to be good. We adopted the roles and profiles patterns, and we also treat the internal modules that we develop at ITV for Puppet like external modules. You know, we're really strict on ourselves. So they have good documentation, they have change logs, they have pull requests to actually make changes to them, and we use semantic versioning. So we know actually if you've made a change and it's a breaking change, you bump that major version number. So anyone using your software, you know that actually that module's had a major change, and actually you kind of, oh, warning, watch out. We also use a system called Puppet file, which means in that infra directory, you actually have a little file that says, these are all the modules I use, these are the versions of the modules I want to use, and you have to all kind of like tie them into your system. So it's actually an example of actually how using tooling, we actually orchestrate and automate and handle a lot of these kind of different situations. So that's with Puppet, and then onto a tool called Terraform. So Terraform is to kind of infrastructure what Puppet is to your platform. We're very early adopters of Terraform. It's a HashiCorp tool. And we use it actually to configure our infrastructure in AWS. So we use it to build our own modules, and that's how we express the ITV way of working at the infrastructure tier. So you just like feed all your variables into it, and what comes out at the other end, we know by definition is going to look like the ITV way. So you know, we treat it like we treat Puppet. We have one repo per module, and again, it goes down to that blast radius thing. There's a weird kind of goism with Terraform, where when you include a module, you specify the full remote path to whichever module it is you want to include. It seems a little bit strange to me because it means scatter throughout your entire code base, all these different references to different modules at different versions. It's actually quite hard to keep track of where anything actually is. So I thought there must be a better way of doing this. Surely there's a way we can have a file at the root of your infrastructure that says, these are the modules I want, and these are the versions, and you can hit a button and it goes. It didn't exist, but I mentioned this to one of my team, and they went away, and the next day they'd created this Terrafile system. So now at the base of each of our infrastructure repos, we have this Terrafile. In there it says, these modules, these versions, and now it's very, very clear what version a particular team is running at, and if you want to do an upgrade for a module, you just tweak that version number, and suddenly everyone kind of gets upgraded for free. So every other team is using that now, and it's kind of a perfect example of being loosely coupled but highly aligned. We have all these different modules, and if you make a change there, you're not forcing everyone to upgrade. They can upgrade at their own leisure, at their own discretion, but it's very, very clear. You make a single change to a version number, and everyone can upgrade. So it goes to say that, you know, all these different modules would be absolutely impossible to manage manually. I think we must have about 50 or 60 different modules between Puppet and Terraform. It would be impossible to manage manually, but through tooling and automation, it makes it a lot easier. So we use a similar kind of approach in terms of Amazon and AWS. So we talked about standardization before. We actually have a kind of common vocabulary for AWS as well. So we talk about products, very, very obvious. We talk about environments. I'm sure you're familiar with what an environment is. We also have ecosystems. And so ecosystem to us is a collection of environments. So if I kind of draw this out here, you see you've got your production ecosystem here, which contains a single production environment, production. You've got your development ecosystem here, which contains multiple development environments. So you may have a QA environment, an SIT environment, a staging environment, a test environment. Those are all part of the development ecosystem. So we're always asking ourselves, does this change affect at the product level, or the ecosystem level, or the environment level, or the role level? And it's very, very clear where it happens. So how does this map into AWS? So you can see here we've got two ecosystems, and they map to accounts in AWS. So every single product that we run on Common Platform gets a pair of accounts. You get your production account and your development account. So straight away, there's a huge blast radius benefit there. Because development is totally air-gapped away from production, there's no way a massive kind of failure of kind of like your platform in here can take out your production instance. That's really, really useful as well. It's also incredibly useful from a billing perspective. You know, so I talk to the accountants at ITV, and I can say, okay, this particular product, here's its dev account. I can tell how much that product is costing per week, per day, per month to develop. Is it worth it? It's very, very obvious from that. And the same for production. You know, we've got a kind of the ITV hub, for example. It costs X amount per month to run. Is it bringing in more than that amount? It makes it very, very clear from a billing perspective. It's also very useful from a security perspective. So IAM roles in AWS are applied per account. So if you give developers full access in dev accidentally, there's no way that can leak through into production because they are totally air-gapped from each other. It's also useful from an API rate limiting perspective because those are applied at the account level. And it means that if, for example, you go Route 53 crazy in your development account, it can't possibly affect the rate limits on your production account. And finally, support costs. So with support, we actually apply the development kind of support package into our development account, surprisingly, and we apply business level support onto production. And because the business level support is actually billed after a certain point as a percentage of your total bill, having that split out actually means we actually concentrate the kind of the expensive support in the place where we actually need it. So it saves us lots of money. Another real big benefit as well is that we have all these things in here. So inside each of these ecosystems, we have our infra VPCs, which sit above everything. So inside those, we put systems like Sensu for operational monitoring, Elk for logging, Grafana for stats and metrics, Console for service discovery, and Jenkins for orchestration. But all of those apply at the ecosystem level. So previously, we would have duplicated those for every environment we had, or maybe even had like some overarching one that sees dev and prod and all the systems together. The problem with that, large blast radius is something that goes wrong, and actually your signal to noise ratio is terrible, because my team is actually responsible for the operational support of all the systems at ITV. They don't want to kind of care about staging or development alerts. They only care about production. So by ring fencing it out like this, we actually kind of increase the signal to noise ratio, and you actually know if an alert has come from Sensu in the infra-prod VPC of an application, by definition, it must be a production alert. So you're no longer having to write email rules to pass stuff through, and you're not having to configure stuff down at that level. It's actually just done by definition by this ring fencing, by this blast radius reduction. So it's a very, very powerful kind of approach. So I mentioned instances before of the Common Platform, because there isn't actually such a thing as the Common Platform. There's actually like 12 of them or 13 of them. It's the same tooling and the same patterns, the same configuration applied multiple times. It goes back to that loosely coupled, highly aligned, because everyone's using the same modules, everyone's using the same config, and actually the team are always kind of bouncing ideas off each other. You know, you are independent, but you're always heading in the same direction. So this is an example of kind of some of the systems we're kind of running on the Common Platform at ITV at the moment. And you can see there's been a massive failure in the development ecosystem of the CD system, our content delivery system. But it can't affect anything else because they're totally ring-fenced and air-gapped. So that's the kind of a really high-level overview of the technology we've got. But the technology we used is about great people to run it. And I say great people, a small number of brilliant people. It's the Jeff Bezos like 2 pizza kind of thing. We're slightly more than that, but actually small number of brilliant people versus literally hundreds at the managed service provider we had. So small number of brilliant people. It's really, really important to get that. And then what do you find? Why 2 must-have criteria for hiring people? They've got to be smart and they've got to be kind. So smart is the ability to adapt to change, because we all know the technology we use today won't be the technology we use tomorrow, and you've got to be pretty smart to keep up. And so kind is the ability to fit into a team. Essentially, don't be a douche. We don't have room for brilliant jerks on the team. We have found that you give people a chance and they'll probably surprise you. You want to throw them in the deep end, and they'll throw them in the deep end, give them armbands and a lifeguard, but they'll probably surprise you. So a perfect example of this is a guy called Cameron on my team. So he is a young lad. He messaged me back after a job posting that I'd put on the Hacker News website for new hires. And he messaged me and said, you know, here's my CV. And I said, hey, Tommy, here's my CV. And he had about 18 months worth of experience. And I think, oh, I'm not sure we've got the capacity to kind of bring up a junior. I don't know if it'd be fair on him rather than us. But he was coming to the UK anyway on a youth mobility visa, so he came in, we had a coffee, he complained the coffee wasn't as good as New Zealand, but that was fine. And we had a good chat, and it was a really, really positive one. He's such a bright guy, but I didn't think we had the capacity to bring up a junior. So we said, okay, I'll bring you in, you'll have an interview with the team, we'll see how you do. So we brought him in, put him in front of the usual kind of interview panel. We did, the whiteboard architecture kind of questions, things like that, and he absolutely smashed it out of the park. In fact, he actually invented sticky load balancing from first principles. He'd never heard about it before, but he came up with it in the interview, so absolute genius. So it's a perfect example where you just like take a bit of a risk, take a bit of a chance on someone, and you may kind of get a good result. So you've hired these smart and kind people. What do you do with them? What do you give them? So there's a guy called Daniel Pink. He talks about theories of motivation, and he talks about these three things. He talks about autonomy, mastery, and purpose. So autonomy is the freedom to make your own decisions. So we just said we hired smart people. Let them do smart person stuff. Don't micromanage them. Don't second guess them. Let them do their own thing. Mastery is the opportunity to become brilliant at something through training and practice. We do internal training, external training, we do conferences, and actually you're surrounded by smart people, and it's like through osmosis. You want to be better. If you're smart, you want to be smarter. And finally, purpose, the belief that what we do actually matters. Now, I'm going to come clean and probably say that I don't think Celebrity Love Island has ever saved a life. But it entertains them, and as far as I'm concerned, that's the next best thing. So, once you've got these smart and kind people, once you've given them autonomy, mastery, and purpose, what do you do with them at ITV? So, there are two sets of ITV, so two sets of engineers at ITV. We've got the embedded or product engineers, and we've got the core team, who I'll come on to later. So if you look at this diagram, this kind of, again, goes back to the different divisions of ITV I mentioned before. Back in the old day, there was one central team, and they were horribly contended, and everyone was fighting over the same resource. So we said, oh, no. We want to reduce the blast radius, and we're going to put at least one engineer dedicated to each division around ITV, and two in the core, who I'll come on to later. And actually, they report into me, but actually, their day-to-day, it's the technology director in that division who gets to decide what happens to that person. It's matrix management, but it actually works. So what do? These people are the first responders, for instance. So the operations team we have is actually that person embedded in that product team. They're generally the first responder. When page duty goes off or sensor alerts go off, it goes to that engineer. But really, their job is to be a force multiplier on the team. They're there to make the team more efficient, more effective. They're there to improve the performance of the pipeline. They're there to help improve the performance of the app. Or maybe write some tools to make the developers' lives easier. And the other thing they do, which is absolutely critical, is they influence operational quality from day one. In the old days, when you had projects delivering software and an operations team they delivered into, the project would go and make whatever they did for a certain deadline, throw it over the fence into the operations team. The operations team go, oh my God, this is horrible. We can't sustain this. Like, well, our project's completed on time and on budget, and actually we've disbanded now. Your problem. We changed that. Because it's the same team that maintains it, and a product is long-lived now, you influence operational quality from day one where it's really, really cheap. So actually the quality of what we produce is much better. So those are the embedded or product engineers. We also have the core team. So the core team are the people responsible for the concept of the common platform itself. So I mentioned the common modules. I mentioned the common Puppet modules, Terraform modules, the tooling, the best practice. These are the people that develop those kind of like bits that everyone else uses, the toolkit that we use. And it's meant to be complete, it's meant to be batteries included. It should actually work out of the box. They're also responsible for the heavy R&D. So back in the day, one of the kind of the project teams and product teams would say, hey, we want to investigate Terraform. Cool, how long is it going to take? And the project manager would ask. And they go, week, maybe 2, maybe 4. And the project manager knew he couldn't fit that onto his Gantt chart, and boom, got it up. So it's really important to note as well, the core team, they're not dictators, they are custodians. Generally what they do is actually create these PRs that are kind of coming in for all the other engineers, making sure they're kind of a good enough quality, merging them in, and then passing them on. So this is how it used to look. So okay, in the old days, but all your kind of your product teams here producing all this stuff, the gray stuff is the common universal stuff. It's the logging, it's the monitoring, it's the alerting, it's the stuff that should be standardized, but it's not. They're all reinventing the wheel. They're making triangular wheels, they're making square wheels, pentagonal wheels. It's not going to work. So the core team kind of comes along and they take responsibility for all those kind of bits. So here she is in the core team taking over the grey, the common shared universal stuff, producing a perfect round wheel and then sharing it with all the other teams out there. And you can tell, you see all the greys disappeared from their graphs. They've actually got more time now to spend on their day jobs, kind of adding value into their particular area of the business. So it's a huge benefit out there. It's also where the security team at ITV can feed in, or the enterprise architecture team. So security will say to the core team, we want you to comply with the CIS benchmark level 2. Great, okay, so they'll go away, they'll scratch their heads, they'll figure out what the hell that means, but they'll work out what changes they need to make to the platform to make that happen. What they'll do, they'll change all the modules, they'll bump all the versions, and they'll release a new version of the common platform, and everyone will upgrade. So I just said release, I just said upgrade. How do you upgrade an entire platform, especially when there are 12 or 13 or 15 or 20 of them around? So go on to the process bit now, this is the really exciting bit. So underpinning the whole of the common platform is something called the specification or the spec. So it's essentially a version standard, and it defines what the platform is, it defines what it isn't. It's essentially the owner's manual for the common platform, and we treat it again like software. So it's stored in the GitHub repo, it's semantically versioned, so admittedly we're on beta 0.1 at the moment, but eventually we're going to release it monthly, and everyone will be expected to upgrade at a certain kind of interval. Everyone should always be within a major version or two of the spec, because otherwise you're not the common platform anymore, you're like the uncommon platform, and people get upset. So drilling down into that, at the very, very top, we have like the charter. And the charter is essentially the highest level goals of what the platform's there to do in the first place. So exactly why we're doing this. When I say to the team, every decision you make should be in service of like one of the charter goals of the common platform. So there are lots of ilities, and if someone can think of a good one for value, I'd appreciate it. But so quality, simplicity, agility, security, longevity, value, and portability. So quality, I define that as doing the right thing once rather than the wrong thing twice. Simplicity, as simple as possible, but no more, because a complicated thing multiplied by a complicated thing is an insanely complicated thing. And like value, I've mentioned value quite a lot. We are FTSE 100, but as small as possible, as large as necessary. It means if you think a triple X, kind of 8XL instance size is the right choice, but you're only running like a single microservice that could actually run on a medium or a micro, then that is probably violating the security charter goal. So at the very top, we've got the charter. Level below that, we've got the policies. So the policies, so they are basically written down common sense. The problem I found is that actually common sense isn't actually that common. So it's the musts, it's the must nots, it's the shoulds, it's the should nots. So an example will be this one. So platform components must be managed through a configuration management tool. So that should be quite obvious for most people. If you've got these systems, you don't want to be making manual changes everywhere. But if you don't actually write it down anywhere, when someone doesn't do what you assume they're going to do, they say, well, it wasn't written down, no one told me. This is where we write it down. And notice as well that I mentioned Puppet at the top of the presentation, but it doesn't mention Puppet here. This document is abstracted from the implementation detail. It says configuration management, but it doesn't care how you do it at this level. But the standards, practices, and principles document helps with that. So this is the day-to-day detail. This is where ecosystems are defined. It's where we define how AWS looks. It defines the DNS naming standards, the alerting standards. So alerting. It's 2 a.m. and my development server just sneezed. Should I page the on-call? So I'd say no. But the document, standards, practices, and principles, says every alert that interrupts someone must be urgent, important, and actionable. So development server sneezing at 2 a.m. meets none of those criteria. The ITV hub is down at prime time. Urgent, yes, we're losing money. Important, yes, we're losing money. And actionable, most likely. Like I said before, my team are generally the first responders for anything that goes wrong on the common platform, so it's probably their responsibility to do something about this. Going down to the bottom gets more exciting, don't I? You get down to the component design and implementation. So these aren't really actually part of the spec. This is basically a requirement for the team to write clean code, include clear comments, and get some peer review. I don't want them writing chapter and verse of documentation, because good code is good documentation. This is kind of an example of one of the Puppet modules we have. You can see that it's got comments, it's kind of cleverly, sensibly named. The parameters that are passed in have sensible names and sensible defaults, which you can override. In sensible defaults, easily overridden. We do validation on the input that you pass in. And actually, that's an example. It's very, very clear, even if you don't understand a Puppet config, what this is trying to do. We do the same thing with Terraform as well. So this is a configuration of Terraform. It's one of the modules I mentioned earlier on for doing launch configuration auto-scaling groups. You can see we've got comments in there. It's sensibly named. Things are kind of split appropriately. The names of the parameters that you pass into the methods are all very obvious, and they've all got kind of sensibly named variables attached to them too. So it's very clear, if you're familiar with this kind of code, what it's actually trying to do. So that's it. So it's been a whistle-stop tour. It's talked about the people, the process, and technology, but it's definitely a journey, and it's definitely not perfect, but there's still plenty more to do at ITV. So thank you very much for your time, and thank you for inviting me in. Thank you. Does anyone have any questions about what we're doing?
Including in the Hangouts.
So I think one thing that strikes me as a big difference from here is that each feature carries its definitions of how it goes into AWS with the feature.
Right.
Can you talk more about the benefits of being centralized versus decentralized on that?
So I think we have like a disadvantage or advantage from different ways. So you have one product, I kind of imagine, that you kind of treat, or kind of different ones.
In the UK at this point, there's about 120 different disparate things in an environment.
Right. Okay. And so how do you kind of group those up? Is there any kind of like I'm seeing smiles from Pete there, so it's
What do you mean group them up, as in terms of?
Yeah, I mean, so when I talk about products, so we have, if I kind of flip back to, I flip back to.
Were you decentralized all along? Did you change?
No. Originally, we were fully kind of centralized, actually. So there was a central operations team, the various dev teams, but all those dev teams passed into kind of a common operations teams. Actually, that's one of the big problems we had, is actually that constant cycle of trying to share knowledge into an operations team that weren't like deeply involved with actually the development of the software. So trying to keep documentation up to date, trying to kind of keep runbooks up to date, when actually that operations team didn't really have the same level of experience or knowledge about the things they were being asked to run. So obviously kind of going with this approach now, the same product team that builds it is the same team that runs it. So they're really intimately familiar with how the system runs.
So vaguely we have the core platform, which is the consumer context, the order context, and the restaurant context. That's the sort of on the night stuff, or on the way up to a sale stuff. Then we've got lately the order fulfillment stuff downstairs in the partner product development, and then some ancillary services provided by another business group, business product development, and then the fork by international, or not by international, but supported by international,
so
which we're converging.
We group a lot of kind of the functionality in like business domains. So actually we find a product team kind of actually when you kind of group like kind of input, output, all the different kind of areas, you generally naturally find like that group could have a circle drawn around them on the Venn diagram, and actually say there's a product team responsible for this particular domain. So if you take, for example, this team here, the hub services team, they're responsible for all the data that actually powers the ITV hub. They're just the API tier, so scheduling, rights, licensing, all that kind of system, but not the hub itself. So the hub itself is actually in this 10-foot team, and also one that's actually not on this particular list. So actually we find where the business domains are, we draw a product boundary around it.
Okay, I totally get the product teams thing, but they're not just owning the code, they're owning the deployment, the Terraform, the...
Yeah, the whole thing, yeah.
Yeah, thanks.
Yeah.
So I guess, are you part of the core team then?
When I have spare time, I like to dabble. So the core team, actually, I mentioned all the other people on the team. Yeah. They all, so these ones here, they report to the tech directors. The core team, actually, I treat the common platform like a product. So I consider myself the product owner, and they report to me.
So you know the docs you mentioned, like the standards.
The spec, yeah.
Very few people actually read standards, right? How do you enforce it in terms of like, do you have tests in place? Do you have like conventions in place that test the conventions? How do you? So you've got like distributed the whole kind of spec around.
Yeah, yeah.
How do you enforce it from an automation point of view? Do you have something like that?
A lot of it's on trust, but the team is kind of extremely collaborative, and I actually kind of have a good view on everything. And actually, they know that from an on-call perspective, if you do drift away from the spec, actually it's going to be your colleagues that are going to get screwed up, because they're going to expect something to be standardized, and they're going to go to a certain address. They're going to trip up, and the next day they're going to go and have a word for you. So actually, it's actually self-governing and self-regulating, which it works quite well. I think because the whole team report to me, if these engineers over here actually reported officially into the other area, and they said, "How cut that corner so we can deliver this on time," that would be different. But because they all report to me, I get to say you aren't allowed to cut that corner.
Cool. Just the last question: how do you define that core team? How do you choose the engineers who make up that core team?
It's not in place at the moment, but it's going to be through rotation. Right. So at the moment, the core team does exist, but actually people are going to rotate through it, because actually you're kind of, it's kind of like if you consider the product team as the front line, the core team is your rest and relaxation. You get like 3 months stint or something back on the core team. You get to do R&D for a couple of weeks with no real time pressure apart from me just asking for coffee every now and then. So the idea is to rotate people through the core team, but we haven't quite got up to that kind of critical mass of people where we can safely start rotating around. But yeah, but I think the way it's going to end up eventually is they're going to be 2 very, very senior people, because they will also be there to be like second opinion as a service to any of the other engineers. So if you put your hand up like an and-on call, I need someone to pair with me, they'll come running and kind of just like work for you for the day, just to kind of like just sit with you and just just talk to you about that.
So looking at that and sort of a little bit of what you just spoke about, how does that organization deal with disruptive mediums like virtual reality or Netflix and stuff like that? If something just popped up out of nowhere and you need to respond to that, how do you account that?
Like an ITV official response, like to let's say kind of Netflix as a competitor, at the product level, as in the level above me, the people actually developing the software, they're kind of responding to that. But I suppose if you think the question, like if there's a new technology that comes around that we need to kind of react to very, very quickly, like I said, I see myself as the product owner of the platform, and the people I host are my customers. And so the old platform actually calcified, it actually kind of like, it was built, big requirements capture, and it never evolved. No one said, is it still fit for purpose? And I mentioned the kind of longevity goal. I'm always trying to look at the technology that's coming down the road, sticking it on my roadmap and then addressing it. If something really crazy came around that we needed to act to really quickly, because we've got that core team capacity, we don't need to screw other people with kind of roadmaps and sprint planning, because I've actually got a capacity there to say, okay, you need this in 2 weeks? Okay, full on R&D, we'll get something out that's kind of like fit for purpose and kind of get it out to you as quickly as possible. So that's kind of, they are kind of our reactionary force that we parachute in to kind of save the day, really.
Have you got any anecdotes or experience or general comments on your experience with Terraform compared to CloudFormation?
So we were very early adopters of Terraform. I think it's about this time last year we started using it, perhaps a little bit too soon, but it's been a night and day difference. I think it takes some investment and it takes some effort, but I think now my engineers love it. It's just so much clearer. You separate everything out in the different modules, and in terms of expressing your ways of working like through Terraform, it's much clearer, and it's just gone are the days where you kind of put a CloudFormation config into AWS, and like 45 minutes later, it would get into that stuck state, and you have to kind of message kind of Amazon support and say it's stuck, and they do something behind the scenes and magically fix it. That doesn't really happen anymore. It's all driven through the API, and actually, if it gets stuck, it's actually quite easy to work out why it got stuck and to fix it. So it's we don't have anything that's on Terraform anymore. Oh, sorry, on CloudFormation now.
And how did you migrate resources away from CloudFormation? Because obviously they're attached to the stack.
Yeah, so I mean, we are quite aggressive when it comes to allowing things to die. So actually, a lot of our migration processes are build a replacement stack to the side and then just flip across to it. So actually, when we did our last migration from CloudFormation onto Terraform, we just said, okay, we know CloudFormation does this for us, express that again in Terraform, play Terraform against a totally different set of accounts until we know it's totally there, run all the tests through it, and as soon as it's great, and then we move the data, sync the data across, just like divert the flow with an E or B or something, and suddenly we've moved, and then wipe out the old one. I think trying to do it in place would be really difficult. But I definitely recommend it.
Any more for any more? Anyone on the Hangout? I'm just seeing HipChat now. Oh, and I've got an alert. Great. Okay.
Cool.
Thank you all for coming. This will probably be the last one that I organise because I'm leaving. So yeah, that's it.
Cool. Thank you very much, everyone. Thank you. Cheers. Thank you.
It's great, isn't it? We use it for. I wish we would use it for like a talking stick during